Let's be real. The internet isn't magic. It's actually a constant, super high-speed conversation. And we're going to listen in on what your computer and some server out there are saying to each other, like right now. Think about it. You do this 100 times a day, right? You type something in, hit enter, and poof, a website appears. But what actually happens in that split second? It's not just a click. It's this incredible journey across the globe that happens faster than you can blink. Let's break it down. Okay, so here's our roadmap. It looks simple, but we're going to follow this exact path all the way from your keyboard to some computer far, far away, and then all the way back. By the end of this, you'll see exactly how a simple request gets turned into a full-blown web page on your screen. Now, before we really dive in, we've got to meet our two main characters. They are the stars of this whole show, the client and the server. First up, we've got the client, and that's you. Well, more specifically, it's the device you're on right this second, your phone, your laptop, whatever. Its entire job is to ask for things. You can think of it as the curious customer in the internet's giant, endless store. And on the other end of the line, you have the server. Now, this is not your average computer. This thing is a beast. Imagine a massive, super-powered librarian just serving up information to millions of people all at the same time. It's the real engine room of the internet. And right here, you can see the real difference. I mean, look at this. Your computer, it's built for you. A server, it's built for everyone, all the time. We're talking multiple processors, special memory that actually corrects its own errors. That's the ECC RAM. And it is literally designed from the ground up to never, ever turn off. Okay, so your client, your computer, needs to ask a server for a web page. But how in the world does it find the right one out of the billions of devices online? Well, it's all about finding the right address. So here's a little secret. Computers have no idea what Google.com means. That's for us humans. They speak in numbers, these things called IP addresses. Every single device connected to the internet has a unique one. It's basically its phone number. So, how do we get from the name you type to the number the computer needs? That is the absolute magic of the DNS, the domain name system. Just think of it as the internet's giant, super fast address book. Your browser just asks, hey, what's the number for Google.com? And the DNS instantly looks it up and gives it the answer. It sounds simple, but without it, the internet as we know it just wouldn't work. All right, once your browser has that IP address, it can finally reach out and talk to the right server. It sends this little message called an HTTP request, which is basically a polite digital handshake. It's your computer saying, hi there, I was told I could find the Google homepage here. Could I please have a copy? The handshake is complete. The connection is made. Now the server has to do its part, and this is where the backend story really begins. And the server just springs into action. I mean, it's not just sending back one little file. No way. It might be checking who you are to log you in, then diving into a huge database to pull out your specific information, all while building the basic structure of the page. And then it bundles all that stuff up to send back to you. It's this crazy flurry of activity, and it all happens in a fraction of a second. The package has arrived. The server did its job and sent back all the raw materials. Now it's your computer's turn to shine. This is the front-end story. This whole process is called rendering, and this is where your web browser pretty much becomes an artist. It takes that raw HTML code and uses it to build the skeleton of the page. Then it uses another file, the CSS, to paint on all the colors, the fonts, and the layout. And finally, JavaScript comes in and brings the whole thing to life, making the buttons clickable and the animations move. It's like a high-speed construction project happening right on your screen. So we've seen the whole journey. But you might be wondering, why is it designed this way? Why this big separation between the client and the server? Well, it turns out this is the fundamental architecture that makes the entire modern internet possible. The biggest reason, one word, scalability. Because you have these incredibly powerful, centralized servers, they can handle requests from 1,000 people or 1,000,000 people, and it doesn't matter. Your laptop would crash and burn trying to do that, but a server? It's built for exactly that kind of pressure. And this really gets to the heart of it, reliability. Think about this. If a hard drive fails in your laptop, it's a disaster, right? Your data could be gone. But on a server that's built with redundancy, a drive can totally fail and no one would even notice. The system just keeps on running. This is exactly what keeps your favorite websites and apps online 24/7. This client-server model has been the backbone of the internet for decades, but it's not standing still. This conversation is getting faster and smarter every single day. So what happens when that powerful server isn't thousands of miles away in some data center, but it's right at the edge of the network, maybe even down the street? Well, that conversation is about to get a whole lot faster. And the internet, as we know it, is probably about to change again.